see
Right.
sulfate.
This,
Lord.
this is the kind of question that I think is far more likely to come up. If this question comes up, this is the kind of thing that I would expect to see towards like the end of the exam paper. If you had something like one of these kinds of questions here, where they're basically just variable acceleration, that's going to be like a question 1 or a question 2. Great, let's just hoover up those marks nice and quick. This one though has got a bit more thinking behind it. However, let's just ignore this whole situation that I've got here for just a brief second. They've just asked you, and it's just for a few marks to show that this is true. After that, the rest of the question is just solve the differential equation, okay? Don't worry. Just be careful, Mehek, because it's disruptive. And so the rest of the question, if you can't do part A, and obviously we are going to be able to do part A, but the whole of this writing is to try and build this. After you've built this, the rest of the question is just solve it, okay? So it's not very hard. It's just the beginning bit can often put people off. And I've said this to last year's class as well. If you can't do one of the beginning bits, just do the rest of it and get all of those marks, because often this is the second half of this bit, part B and part C, can be a huge number of marks. So don't say, oh, I can't do question 4, whatever it is, question 8, I can't do that one because I can't understand what it's about. You can understand what this is about, and you can understand what this is about, okay? So this is talking about a classic filling a container example, and there's obviously going to be different ways that these can be set up, but we'll try and think about what's happening. So it's got a storage tank here. Here's my storage tank. Initially contains 1,000 litres of pure water. Liquid is removed from the tank at a constant rate of 30 litres per hour. So kind of coming out of the tank, and this is 30 litres per hour. Water is leaking. And a chemical solution is added to the tank at a constant rate of 40 litres per hour. So there's 40 litres, shame I can't spell litres, right, per hour going into the tank. So this is going in, this water is coming out. You should already be thinking to yourself, what's happening overall to this tank, right? It says that the chemical solution contains 4 grams of copper sulfate per litre of water. So they're not putting in 40 litres of copper sulfate, they're putting in 40 litres, and each litre has got 4 grams of copper sulfate in it, which is that blue stuff, right? The chemists in here know that. It says, given that there are X grams of copper sulfate in the tank after T hours, and that the copper sulfate immediately disperses throughout the tank on entry. What does that mean, it immediately disperses?
Spreads out.
It like spreads out. Do you think when you put the copper liquid into the tank, it's going to spread out everywhere straight away? It will dilute, but you know when you think about like making a drink with like orange squash or something, does it immediately disperse throughout the whole? It doesn't, does it? So look, I'm already thinking about the model. I don't know why you guys are ignoring this bit. I'm already thinking about the model. Explain how the model could be refined. Well, it's just said that it immediately gets dispersed. We already know it doesn't get dispersed when you make an orange squash in your drink. It doesn't get immediately dispersed. So you've already got your way of refining this model and making it better, okay? It says, show that the situation can be modelled by the differential equation dx dt equals 160 minus 3x over 100 plus t. Now, I'm not even going to think, I want to try and break down what each of these pieces means to begin with, and then we're going to try and build them up. What does dx dt actually mean?
The change in X as T changes.
So it's the rate of change of the copper sulfate, okay? Because the X is X grams of copper sulfate. There are X grams of copper sulfate. So this is the rate of change of copper sulfate. Now, how is the copper sulfate going to change in this tank? Just ignore everything that is written here for me for a second and just look at this picture and tell me why is the rate of copper sulfate going to be changing?
It's increasing and decreasing at the same time.
It's increasing and decreasing at the same time. Fantastic. What's the bit that's making it increase?
The 40 litres being added in every hour.
Yeah, the 40 litres being added in every hour is going to make the amount of copper sulfate increase.
But then it's losing.
But it's also leaking as well. So there's going to be some leaking that's happening too. And that's why we're going to have 2 parts to this differential equation, right? Why is there a negative symbol here? Why is there a negative bit?
Total, which is 1 1,000 times by the 4 grams in it, which is the 160, I'm guessing.
Okay, good. We've already got that bit that sort of idea.
40 times, not 1,000.
Or did you say 1,000? Yeah. So we'll
40 times.
So the 1,000 liters though.
But
That's the
it's
total at the
40
start
litres
though.
per hour.
we're not going to. I don't want us to break it down in that much detail. All I'm saying is, why is there a negative sign? It's connected. Good. We've got this bit must be, because this is the rate of change. If you have a positive rate of change, that means going in. If you have a negative rate of change, you mean going out. So this must be the bit that's going in. This must be the bit that is going out, because it's got negative.
We've got a fixed amount coming in.
We've got a fixed amount coming in.
Yeah.
The amount that's coming out is the weirder bit, because it's a mix of all the dispersed copper sulfate, okay? So you don't have to think about it in this kind of way, but this is the way my brain kind of thinks through it in this way. You wouldn't be given these kind of things, okay? But I like to think, okay, well, I need to know how much liquid is in there in order to work out how much of the copper sulfate is leaking, okay? Why don't we actually let's just deal with this one. The rate of copper sulfate going in is the easiest bit, okay? How much copper sulfate is going in grams?
160 per hour.
160 per hour. So the rate of copper sulfate going in, rate means per hour, it will just be 160, okay? That just came from the 4 grams times by the 40 litres per hour. So that's the 160 that we have here. Rate means per hour. Let's go back to the top half though, because this is the bit that's going to help us deal with how much copper sulfate is going out. How many litres of liquid are in the tank after T hours? Well, there's 1,000 to begin with, and every hour we've got 40 litres being added,
We lose 30.
and you lose 30, so you get 1,000 plus 10T. I'm just going to put a line there so it doesn't look like it's mixed with this. So it's telling you every hour the tank is getting fuller and fuller. But that doesn't necessarily mean that we don't know what the rate of the copper sulfate will be like that. All we know is it's getting fuller. The concentration of the copper sulfate after T hours. So let's not make this too complicated. The concentration is almost like the fraction.
Grams per mole.
So it's how many grams there are, the grams of copper sulfate, divided by the volume. We want to say, like, how concentrated is it? If you think of it like that orange squash, like, how much is in there? So it's just going to be, it's just the amount of grams over 1,000 plus 10T. Okay?
Amount of, okay, yeah.
So the rate of the copper sulfate going out is probably the trickier kind of thing to think about, okay? Every hour, 30 litres is leaking. So how do I connect together 30 litres and the concentration?
Times by 30, no?
Yeah. And the concentration of the copper sulfate.
I'm just guessing from the rate in. So times by 30.
You times it by 30, because if you think about it, this is a fraction, okay? And it's saying this is the proportion of copper sulfate in the water. Well, if there was 5,000 litres, you would times it by 5,000. This is a proportion, a percentage. This is a fraction of the liquid that is copper sulfate. So if we've got 30 litres of this percentage, we find out this fraction or this percentage of 30 litres, which is a multiplication. So the 30 litres and the concentration of copper sulfate, we're going to multiply these things together.
So the X is 1 litre, right, of copper sulfate?
No, the X is the grams of copper sulfate.
In
Okay.
1 litre?
No, this is technically the amount that's in 1 litre, because it's just a fraction, okay? It is just a fraction. It's how many grams there are and how many litres there are. So really the units of this is grams per litre, okay? If it's grams per litre and we've got 30 litres, you just multiply it and you get how many grams there are. And that's how many grams will be leaking per hour, because this is after T hours. So the rate out will be 30 multiplied by X over 1,000 plus 10T, which is just 3x over 100 plus t, which is the thing that they've got there. This is confusing. Like, so the overall rate dx dt is 160 minus 3x over 100 plus t. This would only be worth like 3 marks. And it's just an explanation of kind of things, because they've kind of told you that. Some of the marks would be for saying that the dx dt is the rate of change of copper sulfate. One of the marks would be for saying that the amount coming in, the rate coming in, is just 4 times 40, which is 160. And then 2 of the marks will be for explaining what is this 3x over 100 plus t, and why is it negative. It's negative because it's leaking out, and it's 3x over 100 plus t. I mean, you can kind of see where it's coming from. Even if you just notice, I've got 1,000 plus 10t, they've got 100 plus t. So really, you could manipulate this to make it look like it and almost like force it to happen. Let's just quickly talk about where it all came through one more time. So we've said how many litres there were after a certain amount of time. And then we also know what the proportion of copper sulfate is in any amount of time. We multiplied that by 30 because this is a percentage, this is a proportion. If it was a different rate going in, leaking out, if it was 60 litres per hour, you'd obviously have multiplied it by 60 to find out how much of that 30 liquids, like what's the copper in that 30 litres that you've got, okay? What percentage is in that bit? So we now actually need to do the rest of the question.
Integrate.
So we've got to find the number of grams of copper sulfate in the tank after 6 hours. So let's deal with this. Now imagine you couldn't get 4 marks there, but you definitely could have explained this. You definitely could have explained this, and you definitely could have explained the negative. You may then have got 2 or 3 out of the 4 marks that are there, if you struggled with this bit. And then you're still going to get full marks on the rest of the question.
Will they often give us that first equation?
I-
And then they will tell us.
I've never seen one where they haven't given you that equation, because it's so unfair, because the rest of the question might be worth 12 marks, and if they haven't given you the beginning part, it's really unfair that you can't do the beginning and you can't do the rest. I've never seen one where they haven't given you the differential equation, unless it's very, very, very simple, okay? Unless it's something that's really, really simple. I've never seen one like this without it given. Very good question, though. Okay, how am I going to solve this for part B? What form does this look like? Is this separating the variables?
No, because of the plus or minus.
Because of the plus or minus bit. So what do I need to rearrange it to look like?
To the dy dx plus p of integrate, whatever.
Plus py equals q. So we're going to need to do an integrating factor. So we have dx dt plus
3 over 100 plus t.
3x over 100 plus t. I see what you were saying. You were saying that separately, which is probably a sensible way of doing it, equals 160. So our p of t, remember it's p of t this time, not p of x?
So should we sub t in or not? Because it says 6 hours.
Not yet.
3 over.
No, not yet. You do that all at the end. All the boundary conditions is the last thing we do. So p of t is 3 over 100 plus t. So the integral of p of t dt is 3 ln 100 plus t. So our integrating factor is e to that, which is e to 3 ln 100 plus t, which is just 100 plus t to the power of 3. So we'll now multiply everything here by that. So you've got 100 plus t cubed dx dt plus, well, when you multiply that, you're going to get 3 100 plus t squared x, because you've got the 100 plus t cubed divided by the 100 plus t, which is 100 plus t squared. You with me?
Yep.
Equals 160 100 plus t cubed.
Then
Left-hand side,
the d by dx of 100.
d by dt
d
of...
by dt of 100 plus t cubed x.
Good, let's just double check that that is true. Yeah, because when you differentiate 100 plus t cubed, you get 3 100 plus t squared. And then you've got the x, obviously that comes from that bit. And that's equal to 160, 100 plus t cubed. So 100 plus t cubed x equals the integral of 160, 100 plus t cubed dt. So 100 plus t cubed x equals, what is the integral of this?
80.
40.
So let's start, we'll have 100 plus t to the power of 4.
Yeah, so it's 40 with that.
So it's 40, 100 plus t to the power of 4 plus c. Now, if we want, you can find out what c is now, or we can rearrange. I probably would find out what c is now. To me, I've done all the integration, I can find out what c is straight away. Now, how am I going to even find out what c is? I need to go back to the question for a second and try and extract some information, because now I need the information.
The initial.
I need to know some initial stuff, don't I?
Yeah, so it's
So,
first
okay.
initially
T equals 0.
Initially, that's good. Okay, so t equals 0.
1,000.
X
Oh,
equals 2.
it means that the x is 0.
T equals 0, x equals 0. Why does x equal 0?
It's pure.
Still no grams of
Pure water.
Oh.
So that's the last trick, okay? The last trick in these questions is reading them and saying, okay, well that means t equals 0, that means x equals 0. You know you need to find that information. You know you're going to need it at some point. Depends when you want to find it.
That's why you do
Oh, we
some
can use
T
our
and-
That's why, because this is what you're trying to find the answer for afterwards. That's not going to help you because you want to, we don't know x, we do know t here. We know that t is equal to 6. Just before I actually do this, one of their favourite things to do in this question is to give you some information and it's in litres and then later on it's in millilitres, or in the beginning of the question it's in kilograms and then suddenly it's in grams, or it's in hours and then suddenly it's in minutes. They love to do that. Please, please, please don't just look at the numbers. Please read the question. They also love to do things where they say like x is measured in hundreds of grams. So what they might tell you it's like 600 grams, but actually x is equal to 6 because they've said it's measured in hundreds of grams. You have to read them, otherwise it will ruin your whole question, okay?
And can you say that dx dt is 160?
For what? This one?
Yeah.
At the beginning? Yeah, but we actually only need that for second order differential equations.
Oh, okay.
We only need that for second order differential equations, yeah? Okay, so let's actually finish this off. We have just said that when t equals 0, x equals 0, and that was because it was pure water. So we have 100 cubed. Oh, I don't even know why I'm doing that, because we've got 0. So we get 0 equals 40 times 100 to the power of 4 plus c.
C is minus 40.
Minus 40 times 100 to the power of 4. So now we're going to get, should we just go straight into what x is equal to?
Yeah.
So we get x equals 40 brackets 100 plus t, just to the power of 1, because I've divided by 100 plus t cubed, plus c over 100 plus t cubed, but I actually know what c is, so I don't know why I've done that. So minus 40 times 100 to the power of 4 over 100 plus t cubed. All okay?
Could they ask you what the meaning of C is?
No, it doesn't really have a meaning. It's just the constant of integration. It's going to be dependent on what those initial conditions were that we had, right? So all we need to do to finish off is we want to find out when t is equal to 6. They might have said find it when it's 30 minutes. You might be tempted to put in 30, but you'd have to put in a half, okay? But they want 6 hours, so we're going to get that x is equal to 40, 106 minus 40 times 100 to the power of 4 divided by 106 cubed. Can I use this? So 40 times 106 minus 40 times 100 to the power of 4 divided by 106 cubed. And so we get x is equal to 881.5 grams. to 1 decimal place. Does it say anything about what they wanted it to be given to?
Nope.
Hence, find the number of grams of copper sulfate in the tank after 6 hours. So 881. I mean, I probably should have said 882. 882 grams if you want to do it to the nearest gram.
Hold up, wait.
Now, is that a reasonable amount after 6 hours?
6 hours.
Yeah.
How much?
Yeah.
Yeah, how much was going in per hour?
160.
160. So 6 times 160 is 960.
But then you get rid of.
But some of it's
of the
leaking.
tunnel.
But only like once it gets dispersed in there, lots of it that's leaking is water, and only a bit of it that's leaking is copper. So 882 is sensible. If you got something and it was like 3 grams, or minus 5 grams, or like 58 kilograms, you obviously need to stop and look at it. They love to do at the end of these questions. They might say, someone took a sample from the water and they projected that there was like 985 grams of copper sulfate in there. Like, is this a good model? Well, if they said 985 grams of copper sulfate, what would you say?
Nothing will be leaking out there.
No, would you say it's a good model if they said there were 985 grams? No, it's too far away. If they said 880 grams, you would say, yeah, it's very, very close. Rounded to 2 significant figures, it's the same. If they said 900 grams, you could say the model is quite close, so this is a good model, but it could be refined further. So they love to do that. And when they do that, they're usually giving you a clue if you've got the answer like roughly correct, roughly. Anyway, part D of the question, was it part D or part C? Part C of the question, how could we refine it? We should say, explain how the model could be refined,
Copper sulfate.
add in the fact that the copper sulfate would not immediately disperse. Okay? So you've got another question that you can try. I'd like you to try this one at home. The difference, though, in this question that is about contaminated water being poured into something, same idea, though, is you've got a mixture everywhere of litres and millilitres. The amount that is being poured in has a different rate. It doesn't have a constant amount of like copper sulfate in it, okay? So you can see it kind of here. Previously we had like the numerator was just like the X. It's now got like something that's like a bit different because the amount of water that's being poured in also has like a rate attached to it. Not a rate attached to it, but like a variable attached to it as well, okay? But look, it's 4 marks to do this, okay? This is just coming up with how much the volume of water is in the container. That's a 1 marker. This is just 3 marks to explain this. So you can definitely get 3 out of 4 here. Even if you struggle to do this, you've then got 10 to be able to do the rest of this question. Yeah, so the 8 just for solving it. And then this bit here, this is the thing where I've said they give you some information and you try and work out whether it was actually correct or not. But be careful, because I think this one, they tell you what the concentration of the contaminant is, but you won't have worked out the concentration of the contaminant. You'll have worked out how much contaminant there is. So to work out the concentration, you'll have to divide it by how much liquid there was at that time as well. Okay, you've got to really be careful with the words in this one. So for your homework, I'm going to ask you to have a look at this. I will put the mark scheme for it in the Padlet. In fact, I might put it up there now. Let's enlarge it onto the next page. Although I think this is actually from our exam question Padlet that we've got as well. Not Padlet, you know what I mean. Let's put this here. So I'll have that saved to have a look at. But don't look at the mark scheme too quick, okay? So that's going to be one of your things to do for homework as well.